Well, thank you for coming this afternoon. I'm going to be, sort of from a climate change perspective, we're going to be talking about saline lakes that exist here in the southern high plains, which are a little bit different than what most people assume because they're not playas. So as a starting point, they're not freshwater playas. They're totally different. So basically what we have here is about 40 of these basins that exist here in the southern high plains of Texas and into eastern New Mexico. And they kind of exist on sort of the terminus of the Ogallala aquifer, where the aquifer itself gets relatively thin. And these lakes historically were spring fed, and that's going to be sort of a common theme in regards to sort of changing conditions here in the high plains as well as potential climate change. So you can see here down at about Tioga over to Muleshoe and into eastern New Mexico is where these basins typically exist. These are kind of indicating the general watersheds, not just the basins themselves. But the reason I get into the geomorphology and sort of the history, the millennial history of these, is because they are very, very different than freshwater playas, which a lot of people here in the high plains are much more familiar with. They're large, well-defined, closed basins that are relatively deep. They have ancient origins, all the way back to the Pleistocene or even Holocene, with a lot of different formations depending on the lake. Not all lakes are created equal. Not all lakes have the same geology or hydrology or soil or ecological or natural history value either. The basin surfaces range quite widely in terms of their age, anywhere between 11,000 to 26,000 years before present. Some are considerably older than that. So we're talking millennial age of some of these systems. And some of these, they're unlike a lot of playas, they actually have names. You can see them on a map where they actually have, Bull Lake, Tioga Lake, Mound Lake, Rich Lake, and so forth. And they're actually pretty decent features. However, sort of the normal condition now is not that they're lakes, they're more sort of salt flats with intermittent water and historically some freshwater springs. So this is a figure from Reeves and Warren Wood from back in the 60s and 70s when they were doing some of the work on these systems, particularly at Double Lakes, which is part of the T-Bar Ranch in Lynn County. And what they're showing here is basically you're looking at sort of the top of the Ogallala here, with some of these formations on the east side of these lakes. When these lakes get a little bit drier, aeolian deposition occurs where you have what are called these lunettes form, basically blowout. They form on the east side, and some of them are pretty deep at this point in time. Typically, the current basin surfaces are basically about 10 to 15, maybe 20 feet thick. As you get deeper, they have much older sediment, much older surfaces, some considered to be pre-Wisconsin and other times. But they typically have been enlarged over time by, in essence, a sinking, so to speak. So if you think of these, the basin themselves historically were, in essence, the top of the Ogallala aquifer. So the basins of these lakes were typically saturated to some degree. As the aquifer fluctuates over millennial time, you would have some of that deposition moving eastward. So this variation in sort of the lacustrine deposits that occur are actually quite predictable, or you can reconstruct them in time. So where they have become saline is often a confusing point for people because we talk about freshwater springs as important for birds and current natural history, or even paleo people or paleofauna, but then we refer to them as saline lakes. It's freshwater springs that get deposited onto the surface as the climate here, the wind and heat action tend to evaporate that water, leaving the deposits behind from the freshwater over millennial time, and you can get really very heavy salt and crystal content in these waters. So you can kind of see sort of the deposition of certain minerals such as sapeleolite, smectite, and so forth indicate different periods of time over millennial ranges of time in terms of what's deposited, whether it was a dry period, wet period, somewhere in between. And so basically these salinas or saline lakes are linked to these ideal cycles of water level rise and fall that historically naturally occurred even within the Ogallala itself. But it's the fluctuations in evaporation and concentrations in the water which make these relatively unique systems. But again, these are over millennial time, thousands of years for these processes to occur. And that's sort of the thing to kind of keep in mind in terms of current conditions. So here's a picture of Tioga Lake, which is in Linn County as well. You can see these dune formations here on the lee side of the lake, and you can see them, they're pretty well visible from even Google Maps and those sorts of things. So what you have is this deflation during periods of somewhat more dry conditions, and that's relative in terms of how dry were they over millennial eras. So what you have here is the typically west or southwest winds. When these are dry, they blow them out, they deposit sediment on the east side. The basin basically gets a little bit larger and a little bit deeper. So these lee side dune or lunettes are sort of indicative of what we consider to be the true saline lakes, lacustrine systems here in the High Plains. Playas have some of these as well. They're just much smaller in size and typically thought to be a lot younger in age. But this is sort of a defining feature. And this is a rare occurrence, having these lakes this wet. This was from 2008. This lake right now is about as wet as it was then. That was the last time it had that much water. So if you look at sort of the timeline of this wet-dry cycling, if you sort of go from more recent to very old, lunettes are about 11,000 years before present. That's about how old most of them are. And if you can go back to that period of time, it was really where the water table sort of stabilized between 6,500 and 11,000 years ago, which sort of slowed or stalled lunette formation. Prior to that, the water table naturally dropped, allowing for that deposition. And then if you go back further in time, there were other periods that you can actually look at age in terms of, there were some depositional periods as well, upwards of 50,000 years ago. And what's interesting to note here is that it was estimated that the water table in these lakes was 7 to 8 meters above current level. So that indicates a significant, even natural variation in the Ogallala aquifer, not just sort of human-induced or climate change-induced in more recent times. So, 25 to 30 foot variation in what the top of the Ogallala aquifer was at some point in time. So what this is basically this wet-dry cycling happened naturally, but over very, very long millennial time periods. So this is another way of looking at it, and this is some of these dolomite formations are key features to identify age, as well as conditions of those lakes at those points in time, whether it be algae, silica, other minerals and elements that paleoecologists can identify and age these different strata. It's a little bit more difficult to do so in the basin itself. That's why so much work has been focused on the lunettes. But this gives an idea of the different age, the formations, and then sort of how old some of these structures are now. So this is a picture of Mound Lake, which is on the Terry-Linn County border. This is the current surface of this. This was from 2013, and you read about tufa in like Mono Lake and out in California, the really neat salt structures. It's not that dramatic here in the High Plains. It's typically flat features as opposed to elevated features that grow vertically. But the water in these systems, and Mound Lake is a really good example because it really is very, very salty. Dissolved solid levels of more than 200 parts per thousand. If you think in terms of what a brine is, it's about 36 or 35 parts per thousand. So several-fold greater. Typically mixed of calcium, magnesium, obviously salt, potassium, chlorides, and other minerals. And the composition of those chemicals and minerals vary from lake to lake. But again, this is where that solute concentration occurs, is right on the surface. If you think in terms of the value of these are ancient systems. The museum here at Texas Tech, some of you know Vance Holliday and Dr. Johnson, they have done some work on these over many, many years, and other people as well. And there's evidence of all of these creatures on some of these lakes. So if you go back, mammals, horses, camels, large armadillos, bear, so forth, all of these things were found primarily thought to associate with the freshwater springs that occurred on these lakes over these long millennial times. Obviously, they're all extinct, but they're also pretty well present at well-dated Paleo-Indian sites. One of the things that's of interest in more modern times is the use of these saline lakes by sandhill cranes specifically. There's evidence of sandhill cranes on these lakes here in Texas about 20 to 25,000 years ago. In some other areas in Nebraska, different systems, but we know cranes are a very, very old bird. And these lakes provide critically important, hemispherically important winter roost habitats for sandhill cranes regionally. This picture was from 2008, when this particular lake had anywhere between 30 and 40,000 cranes on it alone. So very, very important. They're also important for Paleo-Indian sites as well. So this is a picture of a hearth here with the sort of sandbags, if you're familiar with those. But this was in association with a spring. This is actually a cairn on one of those western ridges overlooking the lake, and lots of materials and so forth. And what's interesting is that these springs typically are thought to have provided some regular source of water for Paleo people here in the region. So we think about, all right, who cares? I often get that question in regards to snowy plovers and other birds that we're focused on. This is 2013 Tioga Lake. 1 minute looking back. Looking back south, and this is when these systems should be wet. And this was a windstorm in March, spring break time. The wet-dry cycling is very, very sort of fouled up, so to speak, in these systems. So the issue here is really the rapidity in which the declines of the Ogallala are impacting these lakes specifically. So what we're looking at is really an alteration, complete alteration in the rapid change in water surface levels on these lakes over the last 50 years. I know I'm running out of time. I had way too many slides. But this one here is sort of as a take-home message without getting into snowy plovers too much. But in the early 1920s, the state of Texas, the Geological Survey specifically, was looking at these lakes for brine production, for oil and gas production, as well as sites for nuclear waste deposit, which I'm glad they didn't do that, seeing as a lot of these are connected to the Ogallala. That would have been a significantly bad issue. But basically, these are records from the initial surveys out here, indicating how wet they really were in the 20s and 30s. And if you think back when that period was in this country, it was a significantly dry time. So this is really sort of the crux of the problem with these systems. There's only 2 to 4 lakes that really have functional springs any longer. They've become basically precipitation-filled wetlands without the spring connectivity. And that has direct relationships to the snowy plover work that we've been doing over the last 20 years. We're seeing basically an 80 to 90% decline in some of the populations that breed on these systems. And they really are sort of the harbinger, so to speak, of the decline of these systems. And because these are different than playas, they really do have sort of economic, social, political impacts from what's going on with the Ogallalas linked to these systems. So without going any further, we'll sort of leave it for there. Does anybody have any questions?
Yeah, we'll take questions if anyone has questions before we finish up.
Yes.
Yes. Has the lowering of the Ogallala contributed to the fewer springs?
Yes, absolutely. Yeah, Brune. Some of you are familiar with that book. I think in 1981 did a monograph of the springs of Texas, and actually had gallon per minute rates of springs. Most of the springs on these lakes at that point in time were actually still flowing. And so it's a clear correlation between, the way that I sort of describe it is, you have the Ogallala, or the surface of these lakes historically was really muddy. And as the Ogallala drops, you have sort of a drying out of the upper layer of lacustrine sediments, which then begin to collapse, seal off the top, and what you end up having is basically a precipitation-filled surface that's missing the connectivity with the upward moving water. So you have a perched water table on top of that lake that tends to evaporate even more quickly than normal. One of the things that we're concerned with, quite frankly, is the loss of sort of that microbial community that may have existed in that saturated layer that no longer does. Even 15 years ago, most of these, when you walked up to them in the summertime, really stunk of, like salt marsh, sulfur, that sulfur smell. Very few of them do anymore. One or two do. So that sort of processes, I think, are being lost.
More a comment. Tex Reeves years ago found volcanic ash in the Tioga Lake Basin.
Yep.
Which turns out to be Yellowstone ash.
Yep.
So the base of the basin has to be 700,000 or more.
Yeah.
Which
and
is really surprising given some of the carbon dates.
Yeah, the carbon dating of these systems has been refined. There was actually a 2013 study out of University of Wisconsin, one of Warren Wood's colleagues, and I think maybe a former student, Tex Reeves, I'm not sure, did some work at Double Lakes, and they actually backed out and did old lunettes that are sort of really, they're kind of blown out, and they're almost hard to see any longer. So you talk about the age of them, as they got away from the current basin, a mile, half mile, 2 miles away, they were still getting those old dates with lacustrine sediments in it. So you're absolutely right. And I've seen that volcanic ash that you're talking about. It's kind of comes up to the surface in random spots. And the lithic scatter on the lake bottom is tremendous, particularly at Tioga Lake. Yeah, most of the other ones have been kind of picked clean at this point. But.
And All right, thank you very much.
All right, thank you.